because the voltage, I've thrown this switch. If I shut the switch off, there's no continuity. I need to energize the circuit every time you're going to do a voltage drop. Here's the rule. Write this in your notebook. Energize the circuit. I have to allow the current to flow wherever it can, and wherever it stops, I'm going to read it where it stops. So in this case, it stops before here. It stops back at the circuit protection, which is the large circuit protection that feeds this wire. This wire has a circuit breaker on it. So what that means is from this point, and actually from that breaker, all the way through this switch, through the relay, through the coil, back to block ground, there is no power here. So there's no power coming up to here. So that means the path is from this point over into my switch, out of my switch, into my relay, through my relay. The ground, that's a ground. So there is no power here. It's a ground. The power ends at the breaker. So if I open the circuit, I have power at that open circuit. And now I still have a path all the way through everything to ground. So here's what I want you to do now in your notebook. We just figured out how to get a voltage drop test for the actual circuit from an open power supply. So what I want you to write in your notebook is I want you to write battery positive, fuse, and then open the fuse. Make it like an open switch. And then to a switch, to a device, to ground. Make it simple. Don't make it too complicated. So if I draw this out, if I can find my pen, I have a pen here. There it is. So if I draw this out for you, and I'll bring this over if I can, without disturbing too much, I'm going to say battery positive, battery negative. I'm going to come out. I'm going to have my circuit or fuse. Now my circuit fuse looks like this. This is the symbol for it. Okay, and I'll see if I can zoom in a little. There we go. Hold still. So this is a symbol for a fuse. This is the circuit that's way back there that's protecting this circuit up here on my bus bar. And then that goes to a switch. Now the switch is closed. We have closed the switch. That's the switch. Then that goes to the load device. And I'm just going to make a resistor. And then I'm going to make a path to ground. And then I have a path to ground here. So this connection, remember, continues. Now, the voltage coming out of the battery, I should have 12 volts coming out of the battery. I should have 12 volts going into the fuse. I should have 12 volts going out of the fuse, going into the switch, coming out of the switch, going into the load device. I should have 12 volts here. But today, that fuse is open. So that's an open circuit. Now, when we did our voltage drop test just now, I took my multimeter, I put it on volts DC, and I checked from this lead to battery negative, and I read battery voltage. Now my voltage drop test starts. What I'm going to do is take my second lead, and I'm going to go into the fuse. Well, I can't see the fuse because it's way back there, so I can't do that. What I just did was I took my meter lead and I put it on the inlet side of that switch. Now, I normally would have voltage all the way through to this point, but today that circuit breaker just opened. And what happens now is I have continuity through this resistor, which is a load device, all the way through the switch because I closed the switch. Remember, to do a voltage drop test, you should be writing this down. You have to close the switch or energize the circuit. So the switch is closed. I have to have the switch closed. So from this point, through the switch, through the load device, back to battery negative, what is the voltage potential? It's 0 volts. I have 0 volts here at block ground. I have 0 volts at the load device. I have 0 volts here. I have 0 volts at the switch. I have 0 volts here. And I have 0 volts here because this circuit is open. So I have battery voltage into the breaker. I have no voltage making it through the breaker. So this acts like a piece of wire. The load device, remember, has continuity. The coil of wire inside that pull-in coil has continuity. So when I put my meter lead on this side of the circuit, I now have a ground, which is 0 volts. My meter now reads 12 volts because I have a power supply I've tested. So I put my meter lead on this side of my circuit at the battery, or if I could put it on another place, someplace before the battery, before that circuit breaker, I would have voltage potential. And then when I put it on this side, I have no voltage. I have ground. And that tells me that I have an open circuit. That's 100% voltage drop through that circuit breaker. So again, it's a power to a power position. So if I back up and I go to that breaker, I'll bring my meter lead back to the breaker and I'll still read 12 volts. As soon as I go to the other side of the breaker, my meter will go to 0 volts because 12 minus 12 is 0. Another way you can do it is you could take that meter lead and you could put it on ground. And then you would suspect that you should have voltage here before the switch, and you would read 0 because it would be 0 minus 0, and 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 so on. If I start to back up, as soon as I get to where I have power, my meter would read power. That's another way to do it. That's ground minus ground. 0 minus 0 is 0. It works the same way. So the big thing to remember in a voltage drop test is, here's the secret. This is the secret part. You can remember to take it on power and go to 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 power, and the meter reads nothing. Nothing happens. What you have to do is you have to close that switch. Remember, energize that circuit. That's the secret. If you don't energize the circuit, nothing happens.